All right, now let's do a three-set Venn diagram problem with probabilities. So let's suppose A, B, and C are events, and we know 5 things. We know 3 probabilities, then we know a couple of things about sets. If I take the union of A and B and C, I get my entire sample space. And I know that the intersection of A with B union C is empty. And then we have 3 probabilities that we need to determine. All right, so before we even start filling in the Venn diagram, we can actually, I think, solve the first problem. So we know that the probability of A is 0.2. So the probability of A complement, remember, the probability of A plus the probability of A complement has to be equal to 1. So the probability of A complement is 1 minus 0.2, which is equal to 0.8. All right, now for these last two, we're going to have to start filling in this Venn diagram. Okay, so the goal is to start inside and work our way out. But I think we need to deal with the first and the fifth observations first. So the fact that A union B union C is my entire sample space means that there's nothing outside A union B union C. So the probability of that happening is 0. Okay? And now let's look at this fifth one down here. Now we start working our way inside out. So I have A intersect B union C. So let's look at that set. It's in A, and we're also in B or C. So that is this area right here. That's A intersect B union C, and that's the empty set. So that means these 3 probabilities are also 0. All right, now I think we can start using the actual probabilities that we are given. We know that the probability of A is 0.2, so that means the probability of this entire circle that represents the set A is 0.2. Well, since these are all zeros, this is 0.2. Okay, now we keep working our way out. This set right here, this whole part here is B intersect C. But I don't see a number for B intersect C anywhere. So I know that part's 0. I'm just going to put a Y right here because we don't know what that is. And then we keep working outwards. Now let's look at this part. So we know the probability of B is 0.5. Remember, B is the whole circle here, and that's 0.5. So if I add up these 3 and this number, I better get 0.5. So this is 0.5 minus Y. Similarly, based on the fourth fact that we have over there, this guy is 0.7 minus Y. Okay, and then remember that if we add up all these probabilities, we better get 1. So 4 of them are 0, so those won't contribute anything. If I add up the other 4, I better get 1. So 0.2 plus 0.5 minus Y plus Y plus 0.7 minus Y has to equal 1. And then we can just combine our like terms. So 0.2 plus 0.5 plus 0.7 is 1.4. Minus Y plus Y, those cancel each other out. Minus Y is equal to 1. And so if we solve this equation, we get that Y is equal to 0.4. Okay, so now that we know Y is equal to 0.4, we can actually put numbers into this Venn diagram. So since Y is equal to 0.4, I could put a 0.4 right in there. And then 0.5 minus 0.4, well, that's just 0.1. And 0.7 minus 0.4, that's just 0.3. So we filled in this entire Venn diagram, and now we can answer the questions. So the probability of B union C, that's everything in B and C together. That's the 0, the 0, the 0, and then these 3 numbers. We have to add all those up, and we get 0.8. And then the last one, we want the probability of A union B intersect C. So here's A, and here's B intersect C. So we want all the numbers in A union B intersect C added together. That's the 0.2 plus the 0.4, so that's 0.6. And that's our first 3-set Venn diagram problems with probability.